All right, now we're going to look at taking the last example that we did, a simple asynchronous counter, and downloading it to our board. So we're at the same entity, we have a clock, a reset, and a count out. Now our RDS7 board has a clock of 100 megahertz. And what we're going to do is assign LEDs to this count out, a switch to the reset, and use the onboard clock of 100 megahertz. Now, 100 megahertz, we will now be able to see any values being shown on our LEDs. So the first thing we're going to do is slow down the clock to a more reasonable rate. So what I have added in is a new signal for clock divide reg, clock divide next, and I make this a 22-bit unsigned number. Then I've also created a slow clock, which is a single bit of standard logic. So the first thing is to implement this clock divider. It's just another counter, just like the one we have previously done. So it's taking in clock and reset. If reset is equal to 1, we do the clock divide reg equal to 0. So here we can see the benefit of using this others method of assigning 0. Instead of doing double quotes with 22 zeros, we just have to write this value. If the rising edge of the clock occurs, then we do clock divider reg is equal to clock divide next. Clock divide next is clock divide reg plus 1. And then we're going to do our slow clock to the most significant bit. This will give us to around 90 hertz. Then we're going to do a process of slow clock and a reset. If reset is equal to 1, we're going to set our count reg to zeros. If the rising edge of the slow clock occurs, we say counter reg is counter next. Counter next is counter reg plus 1. And then we're going to output the count out is this counter reg. So what we really have done is taken our last example and added in a second adder that's larger in bits to slow down our clock. What we would need to do next is we need to do add sources, add constraint file. Do that, you add a file and add in that RDS7 XDC file. So I have that XDC file up. Let's see the modifications we've done. LEDs, we change LED to be our count out, so we can see what's going to be shown onto the values. Switches, we set one switch to reset. This is the exact same thing we have done in the previous simple example of a combinational logic design being downloaded to the board. For this sequential design, we need to set the clock. So I made a copy. What you'll see is, you will see under clock signals that there is a 12 megahertz clock and a 100 megahertz clock. I copied this 100 megahertz clock just so you, and I modify it down here to say we're going to change clock 100 megahertz to clock. I left this here just so you could see what it is that we'll be modifying. Normally you could just uncomment, change clock 100 megahertz to your clock. All right, then you would go down, run synthesis, I already have done this. Run implementation, I've done that. Generate bitstream, I already done that. So I already have the file that we need to download to the board already built. So let's download it to the board. So we're going to go to Open Hardware. When this new window opens up with hardware, you'll see that there's no content in there. You're going to go down to Open Target, click it once, then click Auto Connect. Then you will see that our chip has been loaded up. You're going to go to the side that says Program Device. You're going to program the XCS50 with our bit file. So we program that. And now it is downloaded to the board. So now let me show you the video of this working. So if we look at our board, you can see that the light's already flashing. That is our counter. I have one switch as a reset. Let me click that. So we have reset the board, or not the board, the counter that we have. We see that it's all zeros, so no lights are on. Once I put reset back down to 0, we can see that count being incremented. And you should see a little bit, it might be hard on the video, that all the lights are flashing. And the ones, the most significant, are flashing a little bit shorter because it's taking longer for those bits to be set. So that gives us to this simple example of showing how to download a synchronous design to our board.